Hi, everybody. So we've already seen a little bit about lava beds. It kind of seems like everybody's been to lava beds in this room. Who knows? So this is another project through the GEODES survey. GEODES is geophysical exploration of the dynamics and evolution of the solar system. There are many themes within GEODES, but our theme is the void spaces theme. And one of our goals is to better understand and characterize lava tubes by applying geological and geophysical measurements towards characterizing these subsurface void spaces. And one of the reasons we want to do this is so we can understand the long-term stability of these lava tubes. There is this hope that we might be able to utilize lava tubes on the moon as shelters for future explorers, but we don't want a shelter that's going to fall down and crush us. So we need to know if these things are going to stay stable over a long period of time. At the top here, we have our full GEODES team. And you saw Naoma talked a little bit about the seismic study we did. There was also magnetic studies. I was part of the fracture mapping team. We were specifically going in the tubes and mapping out how fractured they were as an attempt to figure out just how stable the walls might be. We wanted to see if the cave walls could be observed in visual and thermal imagery and how obvious those fractures were, how easy would they be to detect if it wasn't a person in a lava tube on the moon. We would be able to see things if we sent down a remote sensor. Was the thermal camera appropriate to highlight fractures? Was there something, would we be able to see the really large fractures that might cause problems for long-term stability? And would the fractures be able to be mapped at a level that would be appropriate to perform structural stability analyses? So unlike everybody else, we weren't looking to detect lava tubes. We were specifically looking to make sure that lava tubes, once detected, would be a good place to perhaps build a shelter. Oh, that bottom picture is the fracture mapping team. So our methods, we mapped the fractures and measured them and photographed them at multiple locations within each cave. We were specifically in Valentine Cave, which you've already heard a little bit about, and the Hercules Leg Cave. The first sites were just inside the cave on the right wall. So this is Valentine Cave. That is natural light you're seeing on the right. And then we would go 30 meters back along the wall in each cave and pick a new site and do the measurements again until we reached the end of the wall. Valentine Cave, we only got 7 sites. Hercules Leg, we got 21, a little bit longer. At each measurement site, multiple 3-meter long fracture profiles were taken. So we would take a measuring tape and pull it out along, and then we would go along and note at what distance a fracture crossed the measuring tape. In this image, you can see those arrows are pointing to some big, beautiful fractures. They would not be in this fracture profile because the measuring tape is not crossing them yet. But in the next profile, we would move the measuring tape up 1 meter and do that again, and then move it up 1 meter and do it again. So eventually those fractures were mapped, but not in the profile you're seeing here. We also took thermal images within the FLIR 1 thermal imaging camera. Those arrows are pointing to the same fractures as up here. So you can see that fractures did sort of show up. This is not the best example. I'll show you better examples later. We also used a Schmidt tamper to test material hardness. But after the first 2 sites in Valentine Cave, it wasn't giving us reliable data, and we stopped using it. We did not take measurements in the later caves. So I wrote this abstract hoping I'd be further along in the fracture mapping analysis. I'm afraid it is still ongoing, but do have some results that I can share with you today. One thing we noted, visible imagery was most useful where things like mineralization had occurred. You can see in these images, those fractures really pop, mostly because the vein minerals tended to be a different color than the surrounding host rock. So if we got to the moon and we sent down some remote sensor to look for fractures in a lava tube, if there was mineralization, those are ones we would definitely see. They really pop out. What we also saw were that wet or large aperture fractures were also very easy to observe in the visual imagery. However, smaller hairline fractures were not always clearly identified at distance. You really had to get up at the wall, and when we were doing our fracture mapping, that's when we could see those. Those might be harder ones for a remote sensor to detect. However, they're also less likely to be a problem for structural stability. We would need to really analyze those if there were a significant number of these smaller fractures that could affect our stability. The other potential problem might be that visible imagery required a significant amount of light aimed at the cave wall to capture data. This particular image is at area 1, so it was well lit. But here, when we got into area 5, that is all light from an external source, which actually also introduced heat, which introduced some problems sometimes when we were taking thermal imagery. But you can see here, wet fractures really popped out. So our infrared data, the infrared camera showed that some fractures are observable in the thermal imagery, keeping in mind that the resolution of the thermal imagery is coarser than the visible. But the thermal data demonstrated that you could see those fractures that were conducive and currently permeable. So it highlighted temperature differences with the fractures in the air. So if there was a larger aperture or a wet fracture, those were frequently colder than the surrounding rock, like this large aperture fracture in Hercules Lake Cave, which really popped out. So wet fractures, this is a little harder to see, but those are the wet fractures. And if you go in the area that's circled, you can see that those wet spots are colder than the surrounding rock. It is not as like popping right out in your face the way the large aperture is, but you can detect those wet fractures. In Valentine Cave, thermal imaging was most notable, most helpful, closer to the cave entrance, with the effect diminishing with depth into the lava tube. So this is area 2. We're only 30 meters into the cave, and you can really see these fractures in the thermal imagery, especially the horizontal fracture at the bottom, which is significantly colder, but even the vertical fracture is showing up. However, when we go to area 7, where we're all the way at the back of the cave, I don't know if you can see it. I usually have to see it. I have the arrows pointing to where that fracture is coming out. It's there. You can see it in the thermal imagery, but it doesn't pop. And it might be harder for remote sensing to be able to detect those features. We think this is an effect of temperature homogenization. As you go into depth in the cave, it gets colder, and the air is the same temperature as the walls, and the water is the same temperature as the walls. And so you're not getting those thermal differences anymore that make the thermal imagery really pop out at you. At Hercules Lake Cave, though, you were able to see the temperature differences throughout. Hercules Cave is not as deep. It was a shallower cave. It was longer, but shallower. If you did thermal imagery of the roof, I did not include a picture of this, but the roof was really hot all the way through because it was so close to the surface. So you can see these, the fractures are really popping out. Part of this problem might be because there were multiple roof collapses and skylights in Hercules Lake Cave. It just might mean that the temperature never homogenized. So the walls were always warmer than any kind of air or water coming through the fractures. So I don't have a conclusion slide. I do have my acknowledgement slides. I'd like to acknowledge the Survey Project Geodes. And we did play with the thermal camera a little bit, which was fun. But I just would like to put this in the context of future exploration of the moon and the idea of utilizing these caves for potential human exploration. So we need to figure out ways of determining the stability remotely first, and then getting in there and figuring out with humans where we have the safest places to potentially build a shelter that would already be protected from solar radiation. So these are promising ideas, visual analysis of any fractures that are there. The thermal could be useful, but we have to keep in mind that there are places where the thermal might not be as helpful for detecting fractures as other places. And this is something that we can, in fact, incorporate into future examinations of these sites on the moon. Thank you.